Hello, welcome to section 2-4 and 2-5. We're combining these two sections. They're both kind of smaller sections. One is called about average rate of change and the other is about linear functions. We reviewed linear functions a little bit last section, so a lot of this should be fairly straightforward. Let's start with average rate of change. The average rate of change, and we abbreviate that as ARC, is a fancy way of asking for the slope. And the slope of a line, if you recall, is y minus y over x minus x. That's how we do slope. And when we're in this section in function notation, what we're going to write is f of x1 minus f of x2 over x1 minus x2. So just using function notation, but it means the same thing. Take your y's, subtract them, and put them over your x's. Net change is just the difference of the y's. So it's just the top of your slope. So it's just f of x1 minus f of x2. All right, so several problems going to ask you just to find those two things. Let's do a couple examples. First, let's look at the function f of x equals 3 minus 1/3 x. And I'm going to do x equals 3 and x equals 6. And I'm going to plug these in. F of x1. Now, either one, you can name either one of these 1 and 2. It doesn't matter what order you do them in, as long as you are consistent. So what I always do is I always make the bigger number the first one, but you can do it whichever order you want. So I'm going to call this one the first one, and this is the second one. So I want f of x1. This is for net change, or excuse me, for average rate of change. So average rate of change is f of x1 minus f of x2 over x1 minus x2. So what we're going to do is we're going to take this function and we're going to plug our first number in for x. So we get 3 minus 1/3 times 6. Okay. Then the formula says do that. Then you're going to subtract. So we're going to subtract. And here's the part where most people mess up on this. You got to put brackets or big parentheses because it's minus all of the second thing. And so that minus is going to end up distributing in. If you don't put the brackets on, you will get the wrong answer. Now I'm going to take 2 and plug that in for x. So I'm going to get 3 minus 1/3 times 3. Okay. And then I'm going to divide that by x1, which is 6, minus x2, which is 3. Right? And then we're just going to clean that up. So this is going to be 3 minus 2 minus 3 minus 1. 6 minus 3 is 3, so this is going to be 1 minus 2. So the average rate of change is going to be negative 1/3. Right? And again, that's just the slope of the line. If I ask you for net change, all you're going to do is take the value off the numerator, because it's what the net change is it's just this part, which is just the top of your fractions. So the net change is going to be negative 1. Okay, let's do another example. Here's a function 1 minus 3x squared, and we've got x equals 2 and x equals 2 plus h. Okay, there's going to be a little algebra involved in this. So let's set it up. Average rate of change first is going to be f of x1 minus f of x2 over x1 minus x2. Why do I keep writing the formula? It is because that's a great way to memorize things. If you write the formula down every time you do a problem, by the end of your homework, you'll have your equations memorized. I would recommend not trying to cram at the last minute memorizing things. You want to do it as you go all the way through. So I'm going to again call this x1 and this one's going to be x2. So 1 minus 3 times 2 plus h squared. So what's happening right there is I'm taking this x value and I'm going here and I'm plugging it into this spot right there. That means that the whole thing's going to be squared. That 2 plus h is taking the place of the x in the equation. Right? Then we're going to go minus big parentheses or brackets. And now what we're going to do is we're going to take this 2 and plug that in to the x spot. So now I get 1 minus 3 times 2 squared. And that's all over x1, which is 2 plus h, minus x2, 2. All right, a little algebra on this. So this is one of the first times where we're going to hit what I call potential for black magic in this course. Black magic is highly illegal algebra moves. I want you to take a look at this right here. This is what I'm going to work on. I'm going to show you what the black magic is. Many people want to say that this is 4 plus h squared. That is called black magic. You will lose lots and lots of points. This power does not distribute in over an addition sign. Okay? This is a big red no. The way that you multiply that out is, let's do that in pink down here. Let's take it over here. 2 plus h squared is 2 plus h times 2 plus h. Okay? So you FOIL it out. 2 times 2 is 4. The outside two terms are 2h. The inside two terms are 2h. And the last two terms are h squared. These guys combine, so I get h squared plus 4h plus 4. I've just changed the order of the first and last term, and that is what I'm plugging in right here. It needs to stay in parentheses because that 3 has not distributed in first, or yet. Right? And then over here in this parentheses, I'm getting 1 minus 2 squared is 4 times 3 is 12. Okay? Downstairs, the 2's cancel, and I'm left with an h. Now, I'm going to distribute in the 3. Chink, chink. So I'm going to get minus 3h squared, minus 12h, and minus 12. And then this is going to give me a negative 11, and this minus sign out front is going to make it plus 11. Right? So I've got a negative 12 and 11, 12. Those all cancel. And the only thing I'm left with up top is h terms, so I'm going to factor out an h. You could also factor out a negative 3 if you want. I think that'd be nice. So that's going to leave an h plus 4 inside. And I always take a minute and distribute that negative 3h back in and make sure I did it right. You hop that guy back in, you get negative 3h squared minus 12h. Good, that checks. And then these h's cancel. And this is what we're left with. So this is your average rate of change. Okay. What is your net change? Your net change is the top before any canceling is done with the bottom. So your net change is going to be the top, which is negative 3h, h plus 4. Okay, before it's this step right here before we canceled the h with the denominator. All right, so several problems with that. Again, the goal with these is to help you with your algebra. Just like the first section, there's a lot that look like the difference quotients, and we're just making sure that you can do the algebra. Next thing we're going to do is look at some lines. So we need to first be able to identify linear functions. Linear means line. And the way that you do that is they have a couple characteristics. They have an x term, a y term, no powers. Let's do this, x term or a y term, because they don't have to have both. But they don't have to, they have no powers higher than 1. Okay, and there are no x's and y's in the denominator. And for our purposes, that's a pretty comprehensive list. Okay, so for example, let's throw a couple out here. Y equals the square root of x plus 1 equals x cubed plus 5, xy plus y equals 3x minus 1. And then let's also do one like this. Okay, and the question is, which of these are linear and which is not? Okay, a root. Let's talk about that first. A root is a power of 1/2, and that's something that you learned in Algebra 1 and 2, and is going to be very critical that you understand for calculus. The power right here goes on the bottom of the fraction, and the power inside here goes on the top of the fraction. So what you have here is you have an x term being raised to a power other than 1. Okay? I'm going to actually go up and change this right here to say not higher than, but no powers other than 1. So it doesn't matter if it's lower, if it's anything except 1, then you've got a problem. So that 1/2 is what makes this not linear. Okay, here again, for the same reason, you've got a cube. This is not linear. Now, this is an interesting one. I've got an x term and I've got a y term, so I can check off these first two. Okay, but I've also got an xy term, which is a different kind of term and too many. So this is also not linear. This one has an x in the denominator, so it violates this last requirement. So this is also not linear. This last one, however, has an x term, a y term, nothing else, no powers higher, no fractions with y's or x's in the denominator, so this is linear. At the end of the day, whatever you decide is linear should be able to be written in this form. So if I took this and I solved it for y, I could put it into y equals mx plus b form. None of these others can be done that way. None of the other ones work that way. So that will be a little section on your homework, is identifying linear functions. We will also take some time to review how to graph lines. And I know we did that last section, but just really quickly, let me remind you how to do that. Here's an equation. If it's not in y equals mx plus b form, you need to solve it for y. And you've got this first number sitting by itself. That's your y-intercept, and that's where you start. Remember, this is the y-axis, this is the x. So I'm going to go up to 4, put a point, and then this number right here is your slope. The top is how much you go up or down, depending on the sign. So because this is negative, we're going to go down 1. And the bottom number is how much you go right. And if you always do up, down, top, and right on the bottom, you'll never get it mixed up. So we're going to go from the pink point, down 1, and right 3, and draw our line. And I think it's a good idea to always check that your slope is correct. Remember, we get on the roller coaster on the left-hand side of the line of the graph. And the question is, are you going down? And yes, I am, and I should be because it's negative. So I check that in my head before I move on to the next problem. So So that's a quick review of graphing lines. You will be asked to graph a few lines. And then the last thing in this section is if I give you a line, like that, and I ask you, what is the average rate of change? Now, what am I asking you when I ask for the average rate of change? I'm so glad you remembered. You're finding the slope. So you pick any 2 points that you can identify on this line. It doesn't matter where they are, any 2 that kind of cross at a good cross section, and you count. How many do I go up? How many do I go over? So I'm going up 1, 2, 3, and I'm going over 1. So the average rate is 3. Now, roller coaster, get on the left. Are you going up or down? You're going up, so that means it's a positive 3. If you're going down, it's negative. And in this sense, you could also write the equation of the line. Y equals mx plus b. Your average rate of change is going to be your m. And your b is just your y-intercept. It's the place where it crosses the y-axis. 1, 2, 3, 4. So it's at negative 4. So you should be able to pull both of those pieces of information off of a drawing. And that's it for section